have three very, very exciting guests today. We have Aditya Challapally, who is the machine learning engineer and product lead at Microsoft, and he's also one of the instructors in the course Mastering GenAI for Product Innovation. He will be our amazing moderator, so in a little bit I will kind of hand it over to him, and he will lead us through the session. We also have Michelle Pokrass, so thank you, Michelle, for joining. I know things are very busy right now, and she's the post-training research lead at OpenAI, where she oversees efforts to align models to the needs of power users and developers for technical high-demand use cases across ChatGPT and the API. So very, very exciting to have her. And Chris Potts, he's our beloved instructor and professor at Stanford. He's the professor of linguistics and also by courtesy of computer science. In his research, he develops computational models of linguistics reasoning, emotional expression, and dialogue. And he's really kind of the person to also hear from about all the things that are kind of going on in LLMs right now. And he's also one of the instructors in our generative AI program that should be listed, I believe, on your right. So if you'd like to learn more about them or about the programs or courses we have, we should have some sort of links on the platform. So please feel free to take a look.
Yeah, as Petra mentioned, we have two awesome guests with us, Michelle and Chris, and you just heard their intros, so I won't make them do it again for you, but they're super exciting for two reasons. And we've received a bunch of requests from everybody to get their perspective in terms of an academic perspective of how models are designed or should be designed and how they behave, as well as the industry perspective of those same three questions. And so we're going to walk through those questions as well as what are the most useful deployments both of them have seen and what they think people can do better and what potentially they see in the future. So to start with, Chris, we'll start with you, and Michelle will hit you with the same question. What is one thing most people misunderstand about how language model behavior is shaped?
Fascinating question. Yeah, I don't want to go out of bounds immediately, but I do want to say that I think people might underestimate the capabilities of base models, models that have not been post-trained. I'm sure we'll talk a lot about post-training during this discussion. So I thought I would give a shout out for base models as more capable than people think. I think especially for tasks that it might involve real creativity. I will say that base models might be a little less predictable, and in turn, they'll require more context engineering to get them to do the things that you want them to do. But that could be part of the engineering and creative process. And then you might find that you can do really surprising things with them. So it's a bit unfortunate that for the big model APIs right now, we don't give too much access to base models for people, but maybe we could hope that they become more and more available. And a few points that kind of relate to that. I think, first of all, one reason base models are interesting is that they have a lot of interesting latent capabilities, and the post-training process is often about surfacing those capabilities that are kind of there. And that's why context engineering could also be powerful in terms of kind of bringing them to the fore. And relatedly, if people are thinking then about post-training processes, I would say that regular old continued pre-training, supervised fine-tuning, nothing really fancy, can be a powerful way to get some of those capabilities to come to the surface. It's a pretty predictable, controllable process compared to the most advanced RL algorithms. And in the context of doing SFT, you might think about data curation and other things that would give you good data for bringing out those capabilities. And that's just a nice quick suggestion that I might have for people when they're thinking about doing some kind of post-training process. And I think relatedly, you see that SFT is often a player in most post-training processes mixed in together with fancier algorithms. And I think that does relate to the fact that fundamentally pre-training and the processes that we use for that kind of phase of model creation is very powerful.
Makes a lot of sense. Michelle, same question to you, but I would ask you to add one thing, which is, can you explain really quickly for folks who don't understand potentially the difference between a base model and whatever happens after post-training and why there's a distinction?
Yeah, for sure. So a base model, you can think of it as kind of the absolute most raw form of the intelligence. So like Chris said, this is what comes at the end of the pre-training process where, we're training the model on next token prediction and it's trained on a vast corpus of language. Then there's generally the post-training phase, and this is what me and my team work on, And this is really, like Chris said, where we align models with human preferences or elicit specific capabilities. And, really the base model is incredibly intelligent, but very challenging to use. If you'll ask a question like, how do I ride a bike? The next completions from a base model are going to be like, how do I drive a car? How do I do X? And they're like, not really a helpful assistant. And so ChatGPT was really kind of a magical moment because it was the first time, these models were aligned and easy to talk to. And so that's kind of the magic of the post-training process. I do totally agree with Chris, though, that people kind of underrate these base models, but it's mostly because they're really hard to use. But the power users who can figure out how to use them, do get really cool results. Back to the question at hand, like, what do people misunderstand about language model behavior? I think a lot of folks intuitively believe, that model behavior is done like how other products are shaped, so that you'll like come up with a spec and you'll train the model to this spec and you'll just get out this thing that does exactly what you want it to. But in practice, that's just not how it works. These things are emergent, they're emergent properties of scale, and you often don't quite know exactly what you get. And the thing that comes to mind for me is when I joined OpenAI almost 3 years ago, before ChatGPT, we were actually in the midst of training GPT-4, and I'd played with early snapshots right as I joined. And no one had really intended for these models to be incredible at coding, but the emergent scale of that pre-train was such that this model was now actually incredible for that use case. And so when I joined, I was just spending all my time doing coding problems with the model because that was the final moment of where like that capability emerged. So I think this is the thing that people don't understand. Most of these capabilities are emergent and you can't really plan for them.
And actually, a follow-up question to that, Michelle, which is, you talked about how ChatGPT was a leap specifically in terms of post-training and alignment, and that's because we had base models before. We had several base models before, but ChatGPT was the really one that nailed the experience and obviously made it really easy to use, and that's why obviously it's one for the ages. Similarly, GPT-4.1 felt like a leap in sort of how intuitive it was. As the lead for that training, from your perspective, what changed or what did you do differently in post-training to enable that?
Yeah, totally. So GPT 4.1 was our first model really tailored for developers. We had received a lot of feedback from previous models like GPT 4.0 or 4 or 3.5 Turbo that developers needed some improvements to kind of unlock the full capabilities for their use cases. So there are a few key things that kept coming up again and again, and those were better long context performance, so developers could fill the model's context window with way more relevant documents. Tool calling, so improving the model's ability to call the relevant tools and not give up and kind of display more grit and hardiness when things are going wrong. But also coding, very important for developers. And finally, instruction following, which is of kind of all-encompassing category, but something that's really important for developers because they're often specifying, tens of instructions, and it's really important for the model to follow all of them. So we'd received tons of feedback in all of these dimensions, and actually we were able to develop our own internal evals based on kind of production use cases and feedback that we got. And so 4.1 was really a focus on making the model more usable in these dimensions and less of a focus on, targeting benchmarks or, maximizing intelligence at all costs. And I think it really shows in like the way people use this model is really in these production developer use cases. So I think targeting at that has largely been quite successful.
Actually, a quick follow-up just to make sure everybody understands. What you're saying is what you potentially did differently for 4.1 is you used internal evals as like it was one of the main distinctions versus maybe other or previous models used external evals mostly. Is that right?
Not exactly. I mean, we've always been working on internal evals. I think we just really got serious about it for this model and really serious about targeting kind of usability evals. The other interesting thing is that we did a bunch of alphas with this model. And so we would put it out with a few developers. They'd give us feedback. They'd tell us this thing sucks, and we'd go back and then come back with another model a week later, and move the needle there. So I think that like iterative contact, updating with reality, helps build a much better model.
Cool. Okay, that's actually very interesting. Okay, and Chris, question for you, sort of to follow up on that is, we just talked about how potentially Michelle and her team made the model more intuitive and easy to use, and also potentially more aligned with what the user wants. What do you think makes a model feel intuitive or helpful to users? Like, how do you think we actually measure how GenAI product or GenAI models are useful in practice?
Yeah, fascinating question. I mean, one thing that we might do for this discussion is focus on the systems that surround these models, and the model as just one player in that overall picture. Because I do think that you could have a wonderful model, but if the system surrounding it, the software you build, the way you sample from it, all that other stuff is misspecified, then the experience might be quite poor. And conversely, if you have a relatively weak, small, large language model in the mix, but you've designed a really excellent software system around it, then you might have a wonderful user experience. To take one quick example, if I have a wonderful model, but I sample from it poorly, where I expect it to produce well-formed computer code or JSON, and it produces nonsense, that will be a failure in terms of the user experience, but it might not be a failure of the model. It might be failure of something surrounding the model. And this relates also to things that Michelle mentioned, like what kinds of access to tools does it have? How well does it use those tools? How capable are the tools themselves? All of those things, like they're in the mix at this point in terms of defining what's going to be success for one of these GenAI experiences.
Interesting. Okay, makes sense. So, I guess to both of you, and we'll start with you, Chris, as a follow up. It's you mentioned about these access to tools and access to other things that Michelle mentioned is what potentially determines that level of usefulness. So, one of the things that we potentially see a lot of, especially early on and a little bit now, is the struggle between potentially trying to get models, and I feel like every company's faced this, including Microsoft, of struggling to get models to answer a wide variety of questions, but also be thoughtful about what it can and can't answer. So how do you potentially think about balancing this generalization tension with some measure of sort of truthfulness as you define it? Are these goals sometimes in tension? Like, how do you think about resolving that?
I have some thoughts, I guess. Yeah, that's a complicated question for sure. For the notion of truthfulness, I would just say that I think the best we could hope for is grounding in some claims or some set of documents, and regard that as the thing that we want to have faithfulness to in some sense, and set aside deeper issues of what truth is in the wider world. Having said that, when we think about what we might ask language models to do, I think it's a wide spectrum. In some cases, we want them to do essentially information retrieval, perhaps with some synthesis, and that's a setting in which it's really bad if they do things that we would call hallucination. But we also want to use these models to do things that are more creative and more like brainstorming, and maybe we want to use them to suggest motivated hypotheses based on some claims or some documents. And in those contexts, we want them to stray from being perfectly faithful to what the underlying documents or whatever say. I think we all intuitively know that we might be asking all of these things from GenAI products. And then I would say that the main thing is to figure out what context we're in on the side of the language model, and then also educate people about how model behaviors might vary across the spectrum of things they're trying to do.
Michelle, your thoughts on that?
Yeah, absolutely agree with Chris. It really depends on the domain, like creativity and, document citations are very different environments. I will say more generally, like we train our models to be helpful, usable, and steerable. But I would say like a language model isn't particularly helpful if it won't answer your questions or is lazy in many circumstances. And maybe it's not very useful if the things it's coming up with are not grounded in reality. And so historically, there's been like a delicate balance between those two. And it's something we're working on actively. We actually have some new interesting research directions where we're using models augmented with tools to verify, truthfulness claims during training. And we see that this can have a large impact. And I fully believe, like, in the fullness of time, these will not, it's not a hard limitation. It's really more just about pouring more active research work into the problem. And then a final note, I guess, on the third one, which is, I said, helpful, useful, and steerable. Our latest models, so GPT 4.1 and upcoming models, really have a focus on steerability. And often developers really care about our models not making ungrounded inferences, let's say, or citing, sources either from maybe like code execution or documents supplied or sources on the web. And so these new models are really tailored for steerability and follow instructions regarding this quite well. And so I think for developers who care a lot about this, they're going to see that our models follow their lead there a lot better.
Nice. Okay. That's really
can I make a quick follow-up on that? Because I think this is a fascinating topic, and I have seen that these models have gotten so much better at things that you might call information retrieval with some synthesis, right? Exactly what you'd hope from a modern version of IR, web search, and so forth in this era. Feels like we're approaching a dangerous moment where they're so good that people stop being vigilant. A classic problem with all of these AI-based systems. When we could all tell jokes endlessly about how bad and unfactual all the responses were from the models way back in 2021 or whatever, it was easy to remain vigilant. But as they get really, really good and start to fail only one time out of 100 or one time out of 1,000, it's going to be harder for people even to be alive to the fact that they could be fallible. You enter that moment where people just go on autopilot, to borrow from another domain.
100%.
Yeah, absolutely. I think one thing we lean into here is trying to make all of the sources, the model sites, really visible in the UI.
Yeah.
And there's some other things we're exploring about making like any tool outputs really visible, and so you could follow exactly how the model has produced the output. But I agree, as the models get better, folks definitely check their work less.
And I think it's wonderful framing in terms of humans and interface elements and other things, because these things will never be perfect. That might not even be achievable. We can strive to make them perfect while accepting that they'll fall short. And then it really is about making sure people can be attuned to that fact at the crucial moments.
Makes sense. It goes back to some of the systems around the model that, like you mentioned, Chris. I think we've seen developers who care a lot about citations coming back in the API call so that they can build their systems internally to kind of double check, like, actually, was this quote in the document? In this way, even if you can't get to, 3-4 nines of reliability with the models, then maybe the systems surrounding it can help you get there.
Nice. Yeah, nice.
Really cool. Speaking of steerability and what you were just talking about, Chris, about understanding what goes into a model and understanding how it works and things like this, what do you think, whose values are being encoded in a model, both like in the base training and the pre-training? And why we ask this is we get a lot of questions of people saying, oh, if it's trained on the internet, generally, does it get the internet's bias? And so whether through training data or product decisions or alignment work or whatever, how do you think people decide what counts as good behavior? Chris, and then.
Oh, this is a fascinating question. Who decides? Do we even get to decide? I am reminded in this context, Amanda Askell at Anthropic, she tweeted a couple of months ago, I think in jest, but she said, like, my summer plans are to get fit, have fun, and finish Claude's soul. I suppose that's the idea, that she can shape its behavior into something like the entity she would like it to be. But I'm sure the real answer is that it genuinely takes a village. I guess it's a village of wonky, nerdy AI people, but they need to figure out collectively how they're going to get this model to become something that they could be proud of and trust and so forth, because it really is going to span from data curation and the architecture that you choose and how you run that pre-training process, and then all the training processes that come after that. And then, of course, the system prompt that you design for the thing when it's a product, and everything else that's going to go along with how it generates and how it kind of anticipates user needs. All of that stuff is going to come together into something like the personality, the bias, the perspective that the model will have. I think there's no simple answer. And then, of course, we might think we have complete control over this, but these are complicated things that are hard to understand. And in the end, they're always going to surprise us, just like other people will.
Michelle,
Yeah.
any thoughts on that by any chance? Yeah.
Totally agree. Well, first I'll say we have an awesome model behavior team that I work closely with. To Chris's point of, it takes a village. So I do think it's somewhat an impossible problem to produce a model that is bias-free from everyone on Earth's perspective, right? Like we each, have different priors about the world. And so this is why we think a lot about making our models and the model behavior steerable. Because, if you have strong opinions about how the models should, operate in our product, then, you should be able to encode those in your custom instructions, or, the model should learn and adapt from your conversations. But, that's true for some people, but not for most people. And so the defaults we instill into the model matter a lot. And so because we think this is critical to really interrogate, what kind of values and principles we're instilling in the model, we've produced this artifact called the model spec. And the model spec outlines the intended behavior for our models. And it's open sourced. We've updated multiple versions of it, and we continually solicit feedback. And the reason for this is we think, these things shouldn't be developed, in isolation and without feedback from all of our stakeholders, which is everyone using these models. So I will say we are not always successful in aligning the model to the spec because it's still, active research. And so it's particularly helpful when folks see behavior that, is falling short, that we can show the spec and show actually like this is what we're striving towards. What you're seeing is a bug. We're going to keep working on it and make it better and have the model match the spec fully one day. But that's what we're striving towards. And then, we'll also, I think we're already seeing that sometimes we need to evolve the spec as society changes. We're kind of entering in, the AI era, and folks are becoming more AI native and have more opinions about how these models should behave. And I think the current version of the spec is great and tailored for this current moment. But I anticipate a decade or two from now, we'll actually potentially want, very different behavior or values. And so this thing is a living artifact that society can continue to evolve.
Actually, as a quick... Oh, sorry. Please, Chris, go ahead. No, go ahead.
I just wanted to offer one quick hot take to just emphasize how hard I think this problem actually is. I think you will not get the right behavior from these models if you sort of cleanse your training data pipeline of all the things you're worried about. Take a case like swearing, right? So that's a real social taboo around swearing. You probably don't want these models to swear. You will not get a good outcome if you simply remove all the swears from all the data you ever expose the model to, because what you will get in the end is an agent that is completely naive about swears. You need to do the counterintuitive thing that we do with people, which is to more or less expose them to this and then instruct them about what kind of behavior you want around that particular social taboo. They need to acquire the taboo, and you don't do that by simply not being exposed to it. And swears are a particularly lightweight case of all the things that you might worry about when you worry about models having biases and being unusual or bad social actors. So it's going to be challenging. Michelle, it sounds like very difficult work to achieve the alignment that you're going for.
It is.
And actually, Michelle, the quick follow-up to that is, how do you potentially, when you're building this model spec, how do you work to, prevent your own internal bias, or like the folks working with you imbuing their own personal bias into that model spec? I'm sure you do work around that. So how does that work?
Yeah. Well, first I'll say this is not directly my area, and so I'm kind of speaking a bit for the model behavior team, which is a great group of researchers and product folks. I think the main mechanism there is soliciting a lot of feedback, having it be open, and making sure we're hearing from people who are very different than us. Like, we're often in the tech bubble, and if you ask 10 people at OpenAI, does this thing make sense, you might get 10 yeses, but if you ask 10 people from various different industries, you'll maybe get 10 no's. So that's why the transparency is important. I do have a lot more context on more of the developer portions of the spec, like how our models should behave differently in the API versus ChatGPT by default. And that's really informed by just talking to tons of developers and understanding what defaults they want. So some concrete examples there is that by default, the model in ChatGPT will use Markdown because we render it nicely. And you get a nicer UI in ChatGPT when the model uses headers and whatnot. But if you're building an application through the API, you probably don't want Markdown by default because you're maybe not rendering it. Or maybe you want fewer emojis because you're going to be used in a business context. And so those portions of the spec are really informed by feedback from tons of developers that we work with.
Yeah. Okay, makes sense. It makes sense. Like, it really does seem like there's a lot of thought that gets put into it and a lot of effort that gets put into it to obviously meet the 3 criteria you talked about earlier, steerable, et cetera, but also to work around what Chris was mentioning around the interesting problem of like showing the swear words but then counteracting them. So it seems like it's like a very difficult problem. And at least from what I've seen, it seems like it's severely underestimated how tough it is, across companies. So this is very helpful. Cool. So I guess part of that in terms of like people underestimating how hard it is to do this alignment work. Separately, in terms of underestimation, Michelle, where do you think the market is underestimating potentially like model capabilities? Like what is a set of use cases or a use case that feels unexplored or potentially misunderstood?
Yeah, it's a good question. I think the LLM API industry has gone through a few local maxima, I would say. Like the first version of the API really had product market fit in copywriting, for example. And now I would say LLM APIs have a lot of product market fit in coding applications. But I think these are local and not global maxima. There are many domains in which the models actually maybe do have the capabilities needed to solve tasks, but aren't being used. And the ones that come to mind for me are a lot of enterprise and like support use cases. I really like dream of a day when you never have to wait on hold on a support call. And I think the things letting us down there is not necessarily the models. I mean, obviously there's still work to do on the modeling side, but it's kind of like what Chris was saying earlier. It's actually really challenging to build the systems around the model to build a reliable application. And some things I hear about from developers are they're trying to figure out, how do I best implement like rule-based access controls? And how do I figure out the best way to get my context into the model? And what's the best format for citations? And how do I build my evals, or how do I trace exactly what's going on? So my hot take is that the models are actually kind of there already for lots of enterprise use cases, but we haven't quite figured out the surrounding components yet.
Interesting. Actually, just to follow up on that, we recently published this State of AI report with MIT, outside of this potential work, and we interviewed 150 or 300 executives, and we asked them, and startup leaders, and we asked them potentially why they use ChatGPT so much, and potentially why they don't adopt those same internal tools. And it was this exact same reason that, number one, it was 2 reasons. Number one, that the tools didn't learn their preferences. And number 2, that they didn't necessarily trust the tools as much as potentially they trusted ChatGPT with a simple task. So it makes a lot of sense. And so, Chris, that same question to you, I guess, are there areas in education or reasoning or anything else where you think people are potentially underbuilding with language models?
Oh, yeah. I mean, I second everything you all have said, and I really hope that we achieve what seems possible in terms of opening up access to tutoring, opening up access to legal representation via AI. I think we can offer people who wouldn't otherwise be able to afford it really high quality experiences in these areas. But it is really going to take not only great models, but also a lot of domain expertise and system design and so forth. And I might even just venture, let's go a step further. I think that if more people could feel productive being creative with GenAI tools, we would see a flourishing in what individuals can do and what people can do creatively. For a rough analogy, you could think like TikTok really provided tooling and a platform that made people outstanding at editing videos. And very quickly, they developed their own design language and their own kind of modes of interacting and providing content. Those people would struggle with pro tools for editing video, but TikTok removed that barrier. And if you could imagine we could do the same for Gen AI system development, we might see use cases that none of us are going to think of because we're all on the AI side of this. Yeah. I mean, it's going to be difficult. The more Gen AI becomes pervasive in society, the more we're going to have to figure out as a society how to deal with this. But I do think there are going to be lots of positives for people and for organizations.
Yeah, it makes a lot of sense. And actually, follow up to both of you, but I'll start with Michelle. Michelle, you mentioned that potentially you think the models are there, but the systems around it, around trust and reliability and learning, potentially are there, and potentially memory are not there yet for really these enterprise and support use cases. Do you think, when we speak to these folks, when they come to Stanford and all these things, startup leaders especially, they're always sort of scared or wary that potentially if they build out all of these systems, then potentially the model builders themselves or the models themselves will be able to do it in the future. So potentially they're building redundant infrastructure. So as these models change over time, do you think that's like a feature or a risk, or how should we think about this tension?
Yeah, it's a good question and one that comes up a lot. The API is kind of our arm through which we accomplish kind of distributing the benefits of AGI very widely. And I fully believe that people will build applications and niches that we'll never get to via the first party product because, we just can't build everything. And through developers, we can reach much more of the economy. And so the goal with the API is to make it really easy to build all kinds of these experiences. I think one thing we've already done in this area, for example, is built our own vector stores API and built file search, and we've just seen that this has made it tremendously easier for startups to build applications that require context. We've also built functionality like structured outputs to make it easier to connect your very statically typed and rigid applications to the kind of creativity of LLMs. So I think we'll continue to invest on the API side in these core platform primitives that make it much easier to build applications. And so for startups focusing on the platform layer or the core layer, it's possible we might, build some of those things in-house because they'll help developers. But for folks focusing on specific verticals and niches that, are kind of unrelated to our core competency, I would expect the advances in the platforms and the models to just make their lives a ton easier.
Chris, any thoughts on that? Especially from you, what you've seen?
I mean, I agree with that. The models have gotten so good so fast. And in fairness, a lot of the places where they seem to fall down now are where people need to be taking them and expressing the requirements they actually have for the system and doing the stuff where the model is a piece in the larger software system in order to get where they want to be. I'm not making excuses for the models. By all means, make them better and better and better. But even if we froze the models that we have now, I think there's still an enormous space of things we could do productively that we're not currently doing because of other things around how development is happening and so forth.
Yeah, on that note, I think a lot about the capabilities overhang. If you froze model development at GPT-4, and I think we're still maybe 5 years away from realizing all of the promise that even just that model provides, and the models keep getting better. So I think we're vastly underinvested. It's early internet era.
Actually, and potentially this is a great follow-up to that is, this capabilities overhang thing I think is not super well known, but I think it's, especially in more of the tech world, people understand how far these capabilities have gone, but potentially outside of that, people don't necessarily understand it or haven't been exposed to it. And obviously that's the job of, developers and startups and large companies to expand that and touch more of the economy with AI and increase people's productivity. But what do you think, and this is to both of you, and we'll start with Michelle, what is potentially one principle or set of principles that you think people could do to make these Gen AI products more useful in the real world? Or what do you think is potentially missing that people aren't doing well?
Yeah, I think one area we're falling short a bit is in our model's ability to explain themselves to the user or kind of teach them about what AI is and how it works and how they can get the most out of it. It's a pretty challenging problem for our models to be up to date on what they are and what they can do, because this is all moving so rapidly, and like most of the AI text on the internet is, from GPT 3.5, and so the latest models are often not sure who they are. So yeah, this is somewhere we're focusing more on now. But I think if our models can bring people along better, teach them how to use the technology, then I think we'll just unlock far more utility.
Interesting. Actually, before I ask you the same question, Chris, just a quick follow-up to Michelle. Do you think that is the bridge potentially between, like, because you work with a lot of developers who are building these applications in the real world, and I'm sure you're seeing some who are wildly succeeding, some are potentially growing in that world. What do you think is the one or two principles for those products, obviously for ChatGPT as well, but for those products and separately from the models, but for those products that you think would get them to succeed, or you've seen that works really well for them?
Yeah, I think the most successful AI startups I see all have one thing in common, which is evals. They understand their use cases really well, and they understand how to evaluate the system around it and not just the model. So for them, it's really easy when there's like a new innovation to rerun their evals and see, how can I best use this? How does this whole system working for the user? Because I think building AI products is building just like building any other product. Like, you have to build what people want, and an eval is just expressing, like, does my system accomplish what people want?
Just really quickly, so the audience understands, when you talk about evals, like, can you give a quick example of what, if this is, especially if this is the defining trait that makes startups successful?
Yeah, I'll give an example from our instruction following evals. So an eval is generally just like a prompt and then a way of grading if the model's output, was successful. And so we have this instruction following eval, and an example prompt might be like a really long prompt with the instruction, like, never say, I'm a large language model. And this is like targeting this negative instruction following use case where historically models haven't been very good at following these negative instructions, like don't do X. So here's this prompt we have. It has this like, don't do this. And then the way we grade it is we check, like, did the model say this thing it wasn't supposed to? And so that's like kind of the simplest form of an eval, just a prompt and a simple way of checking if it's done a good job. And then the more complex ones, get a lot more complex. Like, if my application is doing customer support, like maybe the prompt is this complicated problem, and then the final grading is like, did the user's problem get resolved? And so I think the sophisticated AI startups have these prompts which exercise real flows in their products. And then they're able to determine, is this entire system meeting the user's need?
Cool. Really helpful. Okay, really helpful. Okay, Chris, same question to you from the top. What potentially do you think is potentially holding back these GenAI models from being rolled out in the world by developers, or what do you think is a thing they could do to do it better, et cetera?
Great. Well, so Michelle gave a visionary answer. I'm going to give two very tactical things that'll sound boring, but I think they're impactful. But first, I just wanted to double down on the evals thing. And one note I could make there, I think people tend to think evals are going to be a big, expensive thing that they might do later. Maybe they're in a fast development cycle. They don't have time to pause and collect thousands of cases or do a lot of labeling or whatever. I would just exhort people to think even a dozen cases is better than no cases. If you take even just a few minutes to write down a few cases where you think you know what good looks like for the outcome, and then be honest with yourself about whether the model, system, prompt, whatever it is achieving that goal, I think you'll move forward faster. You could kind of like turn Twitter off. Don't worry about what people are saying about the model being the best or the worst or whatever. Let the benchmark results from the academic literature fade into the background, and just 12 cases that matter to you. Of course, if you can do more than 12, that's wonderful. But even 12 is going to be a step forward from just the vibes off one case or just hoping for the best. And I'll say also the evals, maybe Michelle alluded to this, they don't have to involve labeling individual cases. You could think like a software engineer and write unit tests, little things that you expect to see from all input-output pairs, and kind of put your trust in them. Again, it will be better than just the quick vibes thing. And then the more technical thing that I just feel I have to say is that I really wish people, when they created prompts for their systems they're designing, put more few-shot examples in these prompts. I know this is very low level. A few-shot example is just an example, maybe from your test cases, of the behavior that you want to see. And this is so meaningful to me because you see people out in the world, like they've got cursor files where they have just been pleading with the model to do something. 50 times they say it. The model is not doing it because you're probably asking for something very customized, very unusual, and the model cannot overcome its prior just because you told it to. But if you give it a few examples, you will put it into a state where it is much more likely to actually follow the edge case or do the thing that you want. It's a bit more cumbersome, but now I have noticed that places like OpenAI and Anthropic, if you ask them to create few-shot examples for a test, they'll do a great job. Put those in your prompt. Maybe tweak them so they cover the edge cases you care about. And this one small trick, I really think, will lead to better outcomes for the system that you're developing.
I hard agree.
Oh, sorry, go ahead.
I'm often sent like prompts where developers are complaining to me that like the model isn't following the instruction, and I'll go through and I'll read their like 5,000 token prompt, and I'll see that there's like inconsistencies or contradictions, or the few shot examples actually contradict the specified output format. And I think this is a really big thing letting people down. So we actually just put out this prompt optimization tool in our playground. If you paste your prompt in there, we'll actually do a few passes with our models to see like, are there obvious contradictions? And I think fixing stuff like that is a really good first pass.
Nice.
Chris, was that both your tips? You said you had 2 tactical tips.
The evals one that I didn't have a grand vision for evals. Just start small, do a few cases, and then the few shot examples for your prompts was my other thing.
Yeah, actually, a follow up to both of you, because we're also getting a bunch of questions about this in the chat, and we get a lot of questions about this in our classes and in general. And we've sort of answered it a little bit, but what's the best practice in making eval? Like, people often ask questions to us like, oh, do we need to hire all of these data labeling firms, or is it okay if I use like LLM as a judge? And I think like, is there any guidance that you folks would provide here? Because I think this is such a wide new world. Like nobody really understands what's even a best practice. Like what are the best in the field doing? I guess.
Do you want to go first, Chris?
Okay, cool. Yeah, whoever wants to go first.
I'm trying to pitch a pragmatic viewpoint where I say like, really, anything is better than nothing. Judges can be great. You have to place your trust in them. And maybe then you fall back to making sure with a few cases you constructed yourself that the judge is well behaved. But then, yeah, aggregate, information from a judge, I think can be very meaningful. You could think about labeling cases, but as I said, you could think about higher level versions of testing. I'm just pitching, trying to do all of it. I don't know that I could offer a set of best practices that will cover every scenario and every use case. They differ in terms of their stakes, in terms of the quality of the problem, the people involved, and everything. I guess I'm just pitching that teams should get together and think about what success would look like for the system, and then turn that into some kind of evaluation that ideally they can run kind of really continually as they're doing development, and let that thing evolve along with whatever work they're doing.
Michelle?
Yeah, it's a bit hard to give general advice for everything, like Chris said, but we've found that LLM judges, has been incredibly effective for us.
Great.
Maybe sometimes it's hard for a judge to grade, 100 things at once, but if you split out your criteria and do like a pass with each one, you often get much better results. And so something we do with our instruction following eval is actually like, if we have tons of instructions, we might split them out. And for each one, do a pass with another model to say like, was this instruction followed? And this way, you aren't overloading the model with context, and it's a much easier task. The thing that gets a bit meta with LLM judge evals is that you need to eval the judge, which is something we do. Like, you don't need to Chris's point, like any eval is better than none. And maybe your first eval of your judge prompt is to try it on 5 things and see if you agree 4 or 5 times. But we found that evaluating the judges helps us produce better evals on the whole.
Wonderful. Can I follow up on this quickly? Because I want to go even a step further. You all don't have to go with me, but I feel strongly not only judges are productive, but also making heavy use of synthetic data. It's incredibly important. We have a view in academic research, I think, an old view, that the only way to be truly careful is to have all human-created data, all human-created labels. Some of the hardest lessons in my career are around how biased human annotation processes can be and how they can lead to data sets that are really quite distorting of the actual problem that you're trying to solve. They have their strengths, but they have their weaknesses. And so my pitch would be, combine this with some work with some synthetic data. You could try lots of different models so they have different styles. You can put them in different states so they produce different kinds of inputs to battle test the system. You can see what happens on the outputs. I think bringing that in ultimately will teach you more faster than simply insisting that you're a careful person and therefore have to rely only on data that you have created and labeled yourself. There are pitfalls there too.
Any thoughts on that, Michelle?
Yeah, I agree. I mean, there's a place for human data and there's a place for synthetic data. And when you're building your startup, you should just move as quickly as possible. And that's likely going to be synthetic data.
Okay, nice. It makes sense. So, and last question before we wrap it up is, Michelle, let's start with you. What aspect of your work you think is potentially most often overlooked or underappreciated? Is it evals or is it something else?
Yeah, I think we've talked about instruction following a bit here. Instruction following is an interesting capability in that it means a lot of things to a lot of people. And in some sense, it's sort of an AGI complete problem because people will come to me and be like, the model isn't following my instruction. And I look at the prompt and it's like just phenomenally challenging and something out of scope for models currently. So we spend a lot of time untangling this feedback and figuring out like what part of this instruction following problem is actually tractable and, how do we categorize these and, move the needle there. And so for 4.1, we put out in our blog posts, like there's a bunch of different categories of instruction following that we've identified. So some of them are format following. Sometimes it's negative instructions, like I mentioned earlier, or it's following ordered instructions, like first do this, then do that. Or it's like instructions about content. So I think, what people mean by instruction following is often overlooked or much more complex than it seems on the surface.
Interesting. And Chris, do you think there's anything overlooked in your role by any chance of, especially straddling, being a startup advisor, being a professor, and seeing all of this work across different levels?
Yes, I'm trying to think. I mean, this is a bit tangential, but maybe relevant for this audience. We do a lot of work in my group on interpretability for models. And I think currently people are underestimating just how interpretable the best models are. There's a history to this. There was a time in neural networks in the earliest phase when they were uninterpretable and people even thought that was part of why they were interesting, as maybe like a model of human cognition, which would itself be uninterpretable and disorganized. And then more recently, there was a period in the field before 2020, before GPT-3, say, when models were uninterpretable and they did okay at our benchmarks. I think that's because the models were quite bad and so were the benchmarks. And so these models were kind of chaotic and there was very little to explain, but that was kind of intrinsic to the moment we were in. Ever since then, what we have seen is that models, as they get better, develop very systematic structure, human interpretable structure. And I think in many cases, this explains why they are so good at hard generalization tasks. This has been fascinating as a discovery about data-driven learning and what it can lead to. It's opened up incredible doors for people doing linguistics and cognitive science who can now think of these things as interesting artifacts for simulations and so forth that they might want to run. And I really just feel like the field needs to update its view about the interpretability of these objects.
That's fascinating. That genuinely is fascinating. But cool, I think those are all of the questions that we definitely got from the audience in terms of what we definitely wanted to ask you folks. If either of you have any closing thoughts, please feel free. Or else I think we're good. Cool.
Yeah.
Well, that's it.
Thank you so much. It was a great conversation. Yeah, really wonderful.